Hello everyone, welcome to session 12 of QA training. In this session, we are learning black box testing techniques. First, let's talk about testing techniques. A test design technique is a method to derive effective test cases from all possible test cases. These test design techniques are categorized into black box testing and white box testing. Using this test case design techniques, you can improve the quality of the software application. Test design techniques are of two types: black box test design and white box test design. Here we will be focusing on black box test design. Black box testing derives test cases from functional specification of the software. Here the focus is on the focus is on the behavior of the software and the efficiency of its performance. In this black box design, we will not focus on the structural details. Means, in black box testing design, the tester focuses only the input and the output of the software, not how the input and output are generated by the system. So as a tester, in the black box test design techniques, we will focus on input and output of that particular functionality. What input we are giving as a customer, what input you are providing, and then what is the output is generating for that particular input. So here we are not focusing how the input and how the output are generated by the system. Black box testing can be applied for both functional and non-functional mode of the software testing. Let's talk about black box testing techniques. What kind of techniques we will be using in the black box testing? The most common black box testing techniques are equivalence partitioning, boundary value analysis, decision and state transition technique. Let's talk about each and every technique in detail. Equivalence class partitioning. Equivalence partitioning is a black box testing technique where the test cases of the applications are divided into set of logical groups called partitions, which exhibits similar behavior when processed. Here each partition would cover a specific aspect of the application. In equivalence partitioning, we do not have to create test cases covering all the test conditions. Instead, only one condition from each partition is tested. Meaning, say for example, if you are testing the application for equivalence partitioning, let's take one example. Username will allow numerics. That means, right here the scenario says that username will allow numerics. So as a tester, what we will do is we will be dividing all the logical groups. That means, what is logical group here? Numerics is one logical group. That means it is called one partition. Alphabets, it is called one partition. So as a tester, what we will do is we will try to enter numerics in the username. That means you can enter any name, 1, 2, 3, any name. That means if that field is allowing one numeric field, that means if it is allowing 1 or 2, that means it will allow all the numeric fields. Similarly, if it is allowing alphabets A, B, That means if it is allowing alphabets, meaning it will allow all the alphabets. That's why here we said that in equivalence class partitioning, no need to create the test cases covering all the test conditions. Instead, only one condition from each partition is tested. Okay, fine. Next, let's talk about boundary value analysis. To assess the inputs at the boundary of each equivalence partition, we will use this boundary value analysis technique. This type of testing helps to find the most number of defects because the behavior of test inputs to become incorrect when the partition change from one to another. Let's take an example. For example, while testing an application which takes an input between 10 and 1000. So, while testing using boundary value analysis technique, you will design the test cases that cover value 10 and 1000. That means, now just take the same example when the input allowing from 10 to 1000. As a tester, what I will do is, I will see whether my application is allowing less than 10, more than 10, and also on the boundary 10 as well. And also maximum also, what is my maximum is 1000. That means as a tester what I will do, I will see that whether the application is allowing 1000, less than 1000, that means less than 1000 anything 990, 999 whatever, and more than 1000, that means 1001, 1002 like this. So as a tester you are testing the application based on the boundaries. So you will be getting the boundaries for each field. Based on the boundaries you will test the, you will design your test cases. Okay, fine. And one more technique is decision table. So decision table helps to validate requirements that contains logical condition. The input condition and the action will be either true or false. Similar to decision is the state transition technique. The state changes uses the state transition diagram to test the application. A state table shows the relationship between the states and the input, and you can highlight possible transitions that are invalid. Test cases can be designed to cover all the states as well as the transitions. These techniques are used to test the applications with complex business rules. And here I wanted to tell you one more point, you guys. Most of the times when we talk about black box testing techniques, equivalence class partitioning and boundary value analysis are very common methods we will use for this black box testing techniques. That's all for today's session. Thank you all.